Saturn drifts through the outer solar system, a serene world wrapped in rings that circle the planet in a delicate embrace. It is the second largest planet, smaller only than Jupiter, yet possessing a character entirely its own. The rings give Saturn a distinctive appearance, making it perhaps the most visually striking of all the planets, a sight that has captivated observers since the first telescopes revealed their presence centuries ago. When we look at Saturn, even through a small telescope, we see something that seems almost too perfect to be real, a planet adorned with bands of light that float around it in graceful silence. The planet itself is a giant sphere of gas, much like Jupiter, composed primarily of hydrogen and helium. There is no solid surface to stand upon, only layer upon layer of atmosphere that gradually becomes denser as you move inward, eventually transitioning into liquid and then perhaps into strange forms of matter under the immense pressure deep within. Saturn is a world of softness, of gentle gradations, where boundaries between states are blurred and everything flows into everything else in a slow continuum that has existed for billions of years. Saturn's color is a pale gold, a soft creamy yellow that gives the planet a warm appearance despite its great distance from the Sun. This color comes from the clouds in the upper atmosphere, which contain ammonia crystals and other compounds that scatter sunlight in particular ways. The hue is gentler than Jupiter's more vibrant oranges and reds, giving Saturn a subdued beauty, a quiet elegance that suits its peaceful nature. The clouds are organized into bands that wrap around the planet, similar to Jupiter's pattern but less distinct, creating a softer, more uniform appearance. The rings of Saturn are its most famous feature, a system of countless particles orbiting the planet in a thin disk that extends outward for hundreds of thousands of miles. From a distance, the rings appear solid, like a continuous sheet of material, but they are actually made of individual pieces, ranging in size from tiny grains of dust to chunks as large as houses. Most of these particles are made of water ice, frozen fragments that reflect sunlight brightly, giving the rings their brilliant appearance. Some particles are pure ice, while others are mixed with rock or dust, creating subtle variations in color and brightness across the ring system. The rings are remarkably thin compared to their diameter. If you could look at them edge-on, you would see that they are no more than a few dozen feet thick in most places, a flat disk of particles all orbiting Saturn in nearly the same plane. This thinness is a result of collisions between the particles, which gradually flatten the system over time, removing any vertical motion and leaving everything circling the planet in a smooth, level sheet. The particles move at different speeds depending on their distance from Saturn, with inner particles orbiting faster than outer ones, creating a gentle cascade of motion that flows around the planet continuously. The ring system is divided into several distinct regions, separated by gaps where particles are less common. The largest of these gaps is called the Cassini division, named after the astronomer who first observed it. This gap is not completely empty but contains fewer particles than the surrounding regions, creating a visible dark band that separates the bright outer ring from the brighter inner rings. The gaps are created by gravitational interactions with Saturn's moons, which orbit among and around the rings, their gravity gently pulling on the ring particles and clearing certain paths, creating the divisions we see. Saturn is enormous, almost as large as Jupiter in diameter, yet it is much lighter. In fact, Saturn is the least dense of all the planets, so light that if you could find an ocean large enough, the planet would float. This low density comes from its composition, mostly hydrogen and helium in gaseous and liquid form, with only a small core of heavier elements at the center. The lightness of Saturn adds to its ethereal quality, a giant world that somehow feels delicate despite its great size. If you're still awake, that's perfectly fine. Let your thoughts drift along with these ring particles, each one circling Saturn in its own quiet orbit, part of a system that has existed for millions of years. The rings are not permanent features of Saturn. They may have formed relatively recently in the planet's history, perhaps from a moon that wandered too close and was torn apart by tidal forces, or from a collision between two moons that shattered them into countless pieces. Over time, the rings will gradually disappear, as particles slowly spiral inward toward the planet or are lost to space, though this process will take millions of years. For now, the rings remain, a temporary but beautiful addition to Saturn's presence in the solar system. Saturn rotates quickly for such a large planet, spinning once every 10.5 hours or so. This rapid rotation creates a noticeable bulge at the equator, making the planet wider than it is tall. The rotation also helps to organize the atmospheric winds into bands, though these bands are less distinct than on Jupiter, giving Saturn a smoother, more uniform appearance. The winds on Saturn blow at tremendous speeds, particularly near the equator, where they can reach hundreds of miles per hour. Yet when viewed from a distance, these winds create a pattern that appears calm and steady, the whole atmosphere flowing in organized streams around the planet. The planet has storms, though they are less frequent and less prominent than Jupiter's Great Red Spot. Occasionally, large white spots appear in Saturn's atmosphere, bright regions where material is rising rapidly from below, creating temporary disturbances that can last for weeks or months. These storms eventually fade as the winds disperse the rising material, leaving the atmosphere to return to its normal smooth state. The rarity of these storms adds to Saturn's quiet character, a world where dramatic events are uncommon and the overall impression is one of tranquility. Saturn's magnetic field is weaker than Jupiter's but still substantial, extending out into space and creating a magnetosphere that interacts with the solar wind. The field is nearly aligned with the planet's rotation axis, which makes it simpler in structure than some other planetary magnetic fields. Within the magnetosphere, charged particles are trapped and accelerated, though the radiation environment is less intense than at Jupiter. The magnetic field also interacts with some of Saturn's moons, particularly those that have atmospheres or produce material that feeds into the magnetosphere. As we drift onward, we can think about Saturn's moons, of which there are many, ranging from tiny irregular rocks to worlds larger than some planets. The largest moon is Titan, a world wrapped in a thick atmosphere that hides its surface from view. Titan is the second largest moon in the solar system, smaller only than Jupiter's Ganymede, and it is the only moon with a substantial atmosphere, a dense blanket of nitrogen and methane that creates weather patterns and even rain, though the rain is made of liquid methane rather than water. Titan's atmosphere is thicker than Earth's, creating a hazy orange appearance when viewed from space. The haze is made of complex organic molecules, created when sunlight breaks apart methane in the upper atmosphere, allowing the fragments to recombine into larger, more complicated structures. These molecules drift down through the atmosphere, creating layers of haze that obscure the surface below. The atmosphere is cold, far below freezing, and the pressure at the surface is about 50% higher than at sea level on Earth, creating conditions that are very different from our own world yet still fascinating in their complexity. Beneath the haze, Titan's surface is a landscape of hills and valleys, lakes and rivers, though the lakes are filled with liquid methane and ethane rather than water. These hydrocarbon lakes sit quietly on the surface, their shores marked by smooth rounded pebbles of ice, frozen water that is as hard as rock in Titan's cold environment. The rivers flow slowly, carrying liquid methane from the highlands down to the lowlands, creating drainage patterns that look remarkably similar to those on Earth, despite being formed by completely different substances. Titan has seasons, caused by Saturn's tilt as it orbits the Sun. The seasons are long, lasting for several Earth years each, and they bring changes in temperature and rainfall patterns across the Moon's surface. During winter, methane condenses and falls as rain more frequently in certain regions, filling the lakes and causing the rivers to flow. During summer, evaporation increases, and some lakes shrink or disappear, leaving behind empty basins that will fill again when winter returns. This cycle creates a dynamic landscape that changes slowly over the course of Titan's long year. Another of Saturn's notable moons is Enceladus, a small icy world that orbits closer to the planet than Titan. Enceladus is bright white, covered in fresh ice that reflects sunlight with remarkable efficiency, making it one of the most reflective objects in the solar system. The surface is marked by long cracks and ridges, evidence of internal activity that has shaped the Moon over time. Near the South Pole, jets of water vapor and ice particles shoot out from beneath the surface, erupting from fissures in the ice and creating a faint plume that extends into space. These jets come from a subsurface ocean, a body of liquid water hidden beneath miles of ice. The ocean is kept warm by tidal heating, the same process that affects Jupiter's moon Io, though in a much gentler way. As Enceladus orbits Saturn, the planet's gravity flexes the Moon slightly, generating heat through friction within the interior. This heat is enough to maintain liquid water beneath the ice, creating an environment that might, possibly, harbor simple forms of life, though this remains speculative and unproven. The material ejected from Enceladus's jets feeds into Saturn's ring system, adding fresh ice particles that help to maintain the rings over time. The connection between the Moon and the rings is a reminder that the Saturn system is not static but is constantly evolving, with material moving between different components, creating a slow circulation that links the planet, the moons, and the rings together. If you're still awake, that's perfectly fine. These gentle facts about Saturn and its moons are here simply to accompany you, flowing past like the particles in Saturn's rings, each one a small piece of information drifting quietly through your awareness. Another moon worth mentioning is Mimas, a small world marked by a giant impact crater that gives it a distinctive appearance. The crater is so large relative to the Moon's size that the impact that created it nearly shattered Mimas completely. The crater's central peak rises high above the surrounding terrain, and the crater walls cast long shadows that make the feature stand out clearly in photographs. Despite this dramatic scar, Mimas is otherwise a quiet world, heavily cratered and icy, orbiting Saturn in peaceful silence. Rhea is another large moon, the second largest after Titan, though much smaller and without an atmosphere. Rhea's surface is heavily cratered, marked by impacts that occurred billions of years ago when the solar system was young and collisions were more common. The Moon is made mostly of ice, with perhaps a small rocky core at the center, and its surface is bright and reflective, showing variations in brightness that suggest different compositions or ages of the terrain. Iapetus is a moon with a peculiar appearance, one hemisphere bright and the other dark, creating a striking contrast. The dark material is thought to come from dust that slowly spirals inward from more distant irregular moons, gradually accumulating on Iapetus's leading hemisphere as it orbits Saturn. The bright hemisphere is clean ice, relatively untouched by this dust, creating the two-tone appearance. Iapetus also has a ridge that runs along its equator, a strange feature whose origin is not fully understood but which gives the Moon an unusual bulging appearance. Slowly, the description moves on to consider the rings again, which are divided into several main sections given letter names. The outermost bright ring is the A ring, separated from the B ring by the Cassini division. The B ring is the brightest and most massive part of the ring system, containing the most material and reflecting the most light. Inside the B ring is the C ring, which is fainter and more transparent, sometimes called the creep ring because of its gauzy appearance. Beyond the A ring are fainter rings that are harder to see, designated D, E, F, and G, each with its own characteristics and structure. The F ring is particularly interesting because it appears to have a braided structure, with several strands that wind around each other in a complex pattern. This structure is created by the gravitational influence of two small moons, Prometheus and Pandora, which orbit just inside and outside the F ring. These moons are called shepherd moons because their gravity helps to confine the ring particles, keeping them in a narrow band and creating the intricate braided appearance. The E ring is the outermost major ring, extending far from the planet and encompassing the orbit of Enceladus. This ring is made of tiny ice particles, most of them microscopic, supplied by the jets from Enceladus's south pole. The particles spread out along Enceladus's orbit, creating a faint torus of material that is brightest near the Moon's position but extends for hundreds of thousands of miles on either side. The E ring is so diffuse that it is almost invisible except when viewed edge-on with the Sun behind it, when the tiny particles scatter light and create a faint glow. Another quiet detail is that the rings are not uniform in thickness. In some places they are thicker, with particles piled up in concentrations, while in other areas they are thinner, with fewer particles and more empty space. These variations are caused by gravitational interactions with the moons, which create waves and ripples in the rings, patterns that propagate through the particle disk like ripples on a pond. The waves are subtle, causing only small changes in the local density of particles, but they add complexity to the ring structure. Saturn has been visited by several spacecraft over the years, each one adding to our understanding of the planet, its rings, and its moons. The first spacecraft to reach Saturn were simple probes that flew past quickly, taking pictures and measurements before continuing on their journeys. These early missions provided the first close-up views of the rings, revealing details that could not be seen from Earth and confirming that the rings were made of countless individual particles rather than a solid sheet. Later, a more sophisticated spacecraft called Cassini arrived at Saturn and entered orbit around the planet, spending over 13 years studying the system in detail. Cassini observed the rings from many angles, watched the changing seasons on Titan, discovered the jets on Enceladus, and tracked storms in Saturn's atmosphere. The spacecraft carried a small probe called Huygens, which was released to descend through Titan's atmosphere and land on the surface, sending back data about the conditions it encountered and images of the landscape below. Cassini's long mission provided an unprecedented view of Saturn and its moons, showing them in different seasons and from different perspectives, revealing details that had never been seen before. The mission concluded when the spacecraft was deliberately steered into Saturn's atmosphere, ending its journey in a final dive that ensured it would not accidentally contaminate any of the moons with microbes from Earth. The data from Cassini continues to be studied, and the discoveries it made continue to shape our understanding of the Saturn system. If you're still awake, that's perfectly fine. Let these thoughts about Saturn drift through your mind, gentle and undemanding, a slow stream of information that asks nothing of you, just offering quiet details to accompany you as you rest. Saturn orbits the Sun at a distance of about 900 million miles, roughly 10 times farther than Earth. At this distance, sunlight is weak, providing only a small fraction of the energy that reaches Earth. The planet's year is long, about 29.5 Earth years, meaning it takes that long to complete one orbit around the Sun. During this time, Saturn moves slowly through the background stars, taking several years to pass through each constellation of the zodiac. The seasons on Saturn are caused by the tilt of the planet's axis, which is similar to Earth's tilt. As Saturn orbits the Sun, first one hemisphere and then the other is tilted toward the Sun, creating seasonal variations in sunlight and temperature. These seasons are subtle because Saturn generates its own internal heat, radiating more energy than it receives from the Sun, but they are still noticeable, particularly in the changing appearance of the rings as they are viewed from different angles. The rings appear to open and close over the course of Saturn's year, a consequence of the planet's tilt and our changing perspective. When Saturn's north pole is tilted toward Earth, we see the northern side of the rings spread out wide, revealing their full beauty. When the south pole is tilted toward us, we see the southern side. Twice during each orbit, the rings are seen edge-on, and because they are so thin, they almost disappear from view, visible only as a thin line crossing the planet's face. This changing appearance adds variety to observations of Saturn, ensuring that the planet looks different each time we view it over the course of its long year. The temperature at Saturn's cloud tops is very cold, well below -200 degrees Fahrenheit, a consequence of the planet's great distance from the Sun. Deeper in the atmosphere, the temperature rises, and in the interior, it becomes quite warm, heated by the residual energy from Saturn's formation and by the slow contraction of the planet over time. This internal heat drives some of the atmospheric circulation, adding to the energy from the Sun and creating the wind patterns that organize the clouds into bands. Another gentle detail is that Saturn's atmosphere contains trace amounts of various compounds that create subtle colors. Phosphine gives some regions a reddish tint, while other chemicals contribute to the golden-yellow hue that dominates the planet's appearance. These compounds are present in tiny concentrations, but they are enough to affect the way light is scattered and absorbed, creating the soft palette of colors that make Saturn so visually appealing. The gravity on Saturn is similar to Earth's at the cloud tops, despite the planet's enormous size. This is because Saturn is so light and spread out that the surface gravity is not much stronger than what we experience here on Earth. Deeper in the atmosphere, the gravity increases as you approach the denser interior, but at the visible surface, you could almost imagine standing without feeling significantly heavier, though of course there is no solid surface to stand on. Saturn's winds are strongest at the equator, where they blow in a single direction at speeds that can exceed 1,000 miles per hour. These equatorial winds are the fastest in the solar system, driven by the combination of internal heat and the planet's rapid rotation. Farther from the equator, the winds are slower and more variable, creating a pattern of alternating east-west flows that organize the atmosphere into the bands we see. The persistence of these wind patterns over decades and centuries suggests they are deeply rooted in the planet's structure, not just surface phenomena but extensions of circulation patterns that extend far down into the interior. Slowly, as we drift onward, we can think about the way Saturn would appear if we could approach it in a spacecraft, watching as the planet grows larger and the rings resolve into their full complexity. The first thing you would notice is the color, that soft golden glow that suffuses the entire planet. Then the rings would become apparent, a thin bright line that gradually separates into bands of light and dark, revealing the divisions and structure. As you drew closer, you would see the cloud bands on the planet itself, subtle stripes that circle the globe, and you might notice storms or bright spots, temporary features in the otherwise smooth atmosphere. The moons would come into view, some bright and icy, others dark and irregular, each one following its own orbit around Saturn. Titan would stand out because of its haze, a murky orange sphere that hides its surface. Enceladus would be brilliant white, almost glowing in the sunlight. The other moons would appear as points of light that gradually resolve into small worlds, each with its own character and history. Saturn's ring system casts shadows on the planet's upper atmosphere when the Sun is at the right angle, creating dark bands that arc across the planet's face. The rings themselves are illuminated by sunlight, glowing softly, and if you were in the right position, you could see sunlight filtering through the thinner parts of the rings, creating a delicate lacework of light and shadow. The overall impression would be one of beauty and complexity, a carefully arranged system that seems almost designed for aesthetic appeal. Another quiet detail is that Saturn has been known since ancient times, visible to the naked eye as a bright yellowish star that moves slowly through the sky. Ancient civilizations tracked its motion and gave it names, associating it with gods and myths. The Romans called it Saturn, after the god of agriculture and time, a slow and patient deity that suited the planet's unhurried motion across the heavens. When Galileo first observed Saturn through a telescope, he saw the rings but could not resolve them clearly, describing them as handles or ears on either side of the planet. It was not until later, with better telescopes, that observers realized the true nature of the rings, that they were separate from the planet, encircling it in a thin disk. The study of Saturn has continued for centuries, with each generation of astronomers and scientists adding to the accumulated knowledge. Observations from Earth revealed the changing appearance of the rings, the presence of moons, and the cloud bands on the planet. Space missions provided close-up views and detailed measurements, showing the rings in exquisite detail and discovering new moons and new features. Each discovery has added another piece to the puzzle, gradually building a comprehensive picture of Saturn and its complex system. If you're still awake, that's perfectly fine. These quiet facts about Saturn continue to flow, each one a small piece of information, drifting past like particles in the rings, asking nothing of you, just offering gentle observations about this distant world. The particles in Saturn's rings are in constant motion, orbiting the planet at speeds determined by their distance from Saturn. The inner particles move faster, completing an orbit in a few hours, while the outer particles move more slowly, taking days to circle the planet. This differential motion means that the rings are not rigid but are constantly flowing, a river of ice particles that streams around Saturn in an endless cascade. Collisions between particles are gentle and frequent, keeping everything moving in the same plane and gradually grinding the particles down to smaller sizes over time. Some of the ring particles are tiny, no larger than grains of sand or specks of dust, while others are as big as boulders or small buildings. The size distribution varies across the rings, with some regions containing more small particles and others more large chunks. The mix of sizes affects the way the rings reflect light, creating variations in brightness and color that add to the visual complexity of the system. The pure ice particles are bright and white, while those contaminated with dust or rock appear darker, creating subtle patterns across the rings. The origin of Saturn's rings remains a topic of study and discussion. They may have formed from the breakup of a moon, either through a collision or by tidal forces when a moon wandered too close to the planet. Alternatively, they may be remnants of the original material that formed Saturn, leftover pieces that never coalesced into a moon. The rings' relatively bright appearance suggests they are young, perhaps only a few 100 million years old, because dust and impacts should have darkened them over time if they were older. This youthfulness raises questions about how they formed and how long they will last. Another gentle detail is that Saturn's rings are transparent in places, particularly the C ring, which is so tenuous that stars can be seen shining through it when the geometry is right. This transparency reveals that the rings, despite their impressive appearance, contain relatively little material. If all the particles in the rings were gathered together, they would form a moon only a few 100 miles across, a tiny fraction of the volume they currently occupy spread out in a thin disk. The shepherd moons that help to confine and shape the rings are small, irregularly shaped objects that orbit just inside or outside the ring regions they influence. Their gravity creates waves in the rings, patterns that propagate outward from the moon's orbit, and they can also clear gaps, sweeping particles out of certain paths and creating the divisions we see. These gravitational interactions are subtle and complex, requiring precise observations and computer models to fully understand, but the result is a ring system with sharp edges and distinct divisions, a level of structure that would not exist without the influence of the moons. Slowly, the narrative continues, thinking now about the way Saturn appears in the night sky from Earth. The planet is bright enough to be easily visible, shining with a steady yellowish light that does not twinkle like stars. Through even a small telescope, the rings become apparent, transformed from a point of light into a miniature world with visible structure. The sight of Saturn through a telescope is one of the most rewarding experiences in amateur astronomy, a view that seems almost too perfect, as if the planet were a carefully crafted model rather than a real world millions of miles away. Saturn reaches opposition when it is opposite the Sun in Earth's sky and closest to us, about once every year plus 13 days. At opposition, Saturn is at its brightest and largest, the best time to observe it through a telescope. The planet's brightness varies slightly depending on the tilt of the rings, with Saturn appearing brighter when the rings are more open and we see a larger surface area reflecting sunlight. These variations are subtle but measurable, adding another cycle to the many rhythms that govern Saturn's appearance. The study of Saturn has revealed much about how giant planets work, how their atmospheres circulate, how their magnetic fields interact with their surroundings, and how their moons and rings form and evolve. These insights inform our understanding of similar planets around other stars, helping us interpret observations of distant worlds by comparing them to Saturn and Jupiter, the two giant planets we can study in detail. Each discovery about Saturn adds to our general knowledge of planetary science, contributing to a broader understanding of how planets behave. Another quiet detail is that Saturn's rotation creates a slight flattening, making the planet wider at the equator than from pole to pole. This flattening is more pronounced than Jupiter's, a consequence of Saturn's lower density combined with its rapid spin. The shape affects the planet's gravitational field and influences the orbits of the rings and moons, adding complexity to the system's dynamics. If you're still awake, that's perfectly fine. Let your mind continue to drift with these details, floating gently through information about Saturn, a world far away, circled by rings of ice, attended by many moons, a quiet presence in the outer solar system. Saturn's magnetic field creates auroras near the planet's poles, similar to those on Jupiter and Earth but with their own characteristics. The auroras are caused by charged particles following the magnetic field lines down into the upper atmosphere, where they collide with atoms and molecules, causing them to glow. The auroras on Saturn are visible in ultraviolet light and appear as glowing ovals around each pole, shifting and changing as the solar wind varies and as material from the magnetosphere rains down into the atmosphere. The magnetosphere of Saturn is large but less intense than Jupiter's, creating a radiation environment that is less hazardous to spacecraft. The Cassini mission was able to orbit within the magnetosphere for many years, studying its structure and dynamics, observing how it responds to changes in the solar wind and how it interacts with the rings and moons. The magnetosphere is filled with plasma, charged particles that are trapped by the magnetic field and circle the planet in vast currents, creating an invisible but complex environment. Another of Saturn's moons worth mentioning is Dione, a medium-sized world with a surface that shows both heavily cratered terrain and smoother plains, evidence of past geological activity. Dione has bright wispy features on its trailing hemisphere, streaks that may be ice deposits from ancient geologic processes. The Moon orbits Saturn at a moderate distance, completing a circuit every few days, moving through the magnetosphere and experiencing the varying radiation environment. Tessis is another moon with interesting features, including a giant crater called Odysseus that is one of the largest impact structures in the solar system relative to the size of the body it's on. The crater is so large that it covers a significant fraction of Tessis' visible hemisphere, though it has been flattened over time by the relaxation of the icy surface. Tessis also has a long canyon system that stretches across its surface, a feature that may have formed from tidal forces or internal processes early in the Moon's history. Slowly, as the description continues, we can think about how Saturn's system is a miniature version of the solar system itself, with a central body and many smaller objects orbiting it, all bound together by gravity. The rings and moons interact in complex ways, exchanging material and energy, creating a dynamic environment that changes slowly over time. The study of Saturn's system provides insights into how orbital mechanics work, how tidal forces shape worlds, and how systems of multiple bodies can remain stable over billions of years. Saturn's presence in the solar system has likely influenced the other planets in subtle ways, just as Jupiter has. Its gravity affects the orbits of comets and asteroids, and it may have played a role in the migration of planets early in the solar system's history. Some models suggest that the giant planets, including Saturn, moved from their original positions, migrating inward or outward as they interacted with the disk of material from which the planets formed. These migrations would have had profound effects on the rest of the solar system, potentially scattering small bodies and influencing the final arrangement of the planets. Another gentle detail is that Saturn's low density means that its internal structure must be different from Earth's. While Earth has a large iron core, Saturn's core, if it exists, is likely made of rock and ice, surrounded by layers of metallic hydrogen and then gaseous hydrogen and helium. The exact structure is uncertain because we cannot see inside the planet, but models based on gravity measurements and other data suggest this general arrangement. The temperature structure of Saturn's atmosphere creates stable layers, with warmer gas below and cooler gas above. This stability limits vertical motion, so most of the atmospheric movement is horizontal, along the bands. The winds blow steadily within each band, carrying clouds and small features along with them, creating the smooth appearance that characterizes Saturn's visible face. If you're still awake, that's perfectly fine. These gentle facts about Saturn are simply here, flowing past quietly, offering information that asks nothing of you, just accompanying you as you rest. Saturn's year is long, and during this time, the planet experiences seasons that affect the appearance of the rings and the atmospheric patterns. The seasons are most noticeable in the changing tilt of the rings, which opens and closes the view of the ring system from Earth. The atmosphere also shows seasonal changes, with storms appearing more frequently at certain times and the band structure varying slightly in intensity and position. The Cassini spacecraft observed these seasonal changes during its 13-year mission, watching as Saturn moved from northern winter to northern summer, documenting the gradual shifts in cloud patterns, the evolution of storms, and the changing appearance of the rings as the sun's angle changed. These observations provided a unique view of how a giant planet's atmosphere responds to seasonal forcing, revealing patterns that could not be seen from brief flybys or short-term observations. Another quiet detail is that some of Saturn's moons orbit within the rings or very close to them, creating intricate gravitational interactions. These moons can create waves and structures in the rings, and they may also accrete material from the rings, slowly growing over time. The relationship between the moons and the rings is complex and not fully understood, but it is clear that they influence each other in many ways. The F ring, with its braided appearance, is particularly dynamic, changing its structure over months and years as the shepherd moons Prometheus and Pandora perturb the particles. Sometimes the ring appears as a single strand, while at other times it separates into multiple strands that wind around each other. Small clumps of material appear and disappear, and bright knots move along the ring, creating a constantly changing appearance that has fascinated observers since the ring was first seen clearly by spacecraft. Slowly, the description moves toward a close, thinking about Saturn as a whole, a giant planet wrapped in rings, attended by dozens of moons, a complex system that has existed for billions of years and will continue to exist for billions more. The planet drifts through space at its great distance from the Sun, turning steadily, its rings reflecting sunlight, its moons following their orbits, all part of a quiet dance that continues endlessly in the darkness. Saturn has been a source of wonder and inspiration for as long as humans have looked up at the sky. Its rings make it unique among the planets visible to the naked eye, though the rings themselves were not discovered until telescopes revealed them. The planet has appeared in art, literature, and mythology, a symbol of the broader universe and a reminder that there are worlds beyond our own, each with its own character and beauty. The study of Saturn continues, with new observations and new analyses revealing additional details about the planet, its rings, and its moons. Future missions may return to Saturn, carrying more advanced instruments to study specific questions or to explore particular moons in greater detail. Each mission will add to the accumulated knowledge, building on what came before and opening new avenues of inquiry. And so the description of Saturn comes to a gentle close, not with a dramatic conclusion but simply by letting the information fade away, much as the light from Saturn itself fades when dawn approaches and the stars disappear into the brightening sky. The planet continues its slow journey around the Sun, its rings continue to circle, its moons continue their orbits, all happening in the silence of space, far from our everyday concerns, a distant world that we can study and admire, a bright steady light in the night that has watched over Earth for eons and will continue to do so for eons to come, a peaceful presence in the outer solar system, adorned with rings of ice that catch the sunlight and shine with a soft and beautiful glow.